This video will be an introduction to Competency 16. In this video, we will use the concept of a number cube or die and deck of cards. If you're not familiar with a standard deck of cards, make sure that you are before the exam. It is possible that questions could relate to drawing single cards out of a deck of cards. Number 1. What is the complete sample space created by an experiment rolling an ordinary number cube once? By number cube, of course, they mean a die. A sample space is or represents the possible outcomes. For a deck of cards, that would be 52 cards, meaning 52 outcomes. And for a standard number cube with the faces 1 to 6, this would be 6 possible outcomes. Number 2, a 5-sided figure is numbered 1 to 5 on each of its faces. If the figure is rolled twice, how many outcomes are in its sample space? Well, for this question, we are only concerned with the outcomes. So for each roll, we have 5 outcomes. So let's see here. Okay. So there's the first roll. Here's the second row. We will multiply in this situation. So 5 times 5 is 25. But also notice that 5 squared is also 25. Okay, let's go to our calculator. The point of using the calculator for a simple problem like this is just to get used to it, the TI-84. The faster you can use your calculator, the better you're going to be on the test. So we have 5 squared. Notice which button I push, and push enter, 25. Perfect. Now let's ask ourselves, what would happen if we rolled the die number cube 4 times, 3 times? Let's say 3 times. There's 1, 2, 3. Well, what do we see? Well, we see 5 to the 3rd power. You may not know what that equals. I don't always remember myself. So if we push 5, we can't just push x squared. That's why we have the caret up. Caret up, that gives us 3rd power. Press enter. That is 125 outcomes. Now let's say we roll 4 times. Before I write this down, let me make a point. When you roll a die, unlike other things like drawing things out of a bag, no matter how many times you roll, that number of outcomes for each roll will never change. There'll be other videos that come up, or maybe you've seen other videos online that talk about with replacement, without replacement. A die or a number cube of any kind with faces, a certain number of faces, is never going to be without replacement. You're not going to take and scratch the number off once and definitely you're not going to be asked a question like that. Okay, so let's roll this. 1, 2, 3, 4 times, obviously. 5 to the 4th power. I don't remember. Well, I do know what that is because I've done this several times. However, again, the process is 5, caret up, 4th power, press enter, 625 comes. So now that you see the pattern to this. Okay, high could erase would be great. Okay, if you can see the pattern of this, then you're not going to have a problem. Simple question, which you could actually be asked this embedded with other criteria or a different kind of shape or another situation or in combination with something else. So you need to be aware of what the process is. Before we end this question and we go on to the next question, let's think about this. What if we had two different kinds of dye? Okay, well, let's see here. Okay, let me draw a line here. So let's say we have our five-sided. Well, I don't think I like the way that looks. Let's just change our color here. Okay, well, let's go back to our color here. Okay, right. Let's say we have our five-sided, but then let's say change color for this part. Okay, pick something else. Okay, so let's say we go to a regular die. We have a five, we roll our five, then we roll our six. Well, naturally, that's going to change everything. That's going to change our outcomes because we've went from five sides to six sides. So 5 times 6 is 30. So we're not going to get that nice pattern of second power, third power, fourth power because we're using two different dots. Just wanted to make a point of letting you see that this would be a completely different situation. So the answer to our question is 25 outcomes. Number 3, an experiment requires drawing 3 cards from an average deck of 52 playing cards. If the cards are drawn without replacement, how many outcomes are in its sample space? Okay, this is a little different. We need to note that each event is when a card is drawn. Not only that, okay, let me change colors. Okay. Not only that, each card is unique, meaning that in a deck of cards, we don't have repetition. There are not two 10 of diamonds. There's only one. It's unique. Since each card is unique, the order of the cards drawn will matter, which means this is a basic permutation. And this is our permutation. So n in our permutation is a total number of outcomes possible, which for a deck of cards is 52. So we have 52. P for permutation. And then the R is the required or desired possibilities. Well, we're discussing 3 cards. So we have 3 desired possibilities. So you could calculate all these things individually. However, we've got something great. We've got our TI-84, which will make things a lot faster. So we need to push alpha, window, and we're interested in number 7. So you actually have to push number 7. So our first little box is highlighted. So we push 52, then arrow over. How many outcomes are we interested in? We are interested in those 3 cards. We push enter and we get 132,600. Absolutely, that is our number of outcomes. Well, if you're skeptical and you've reviewed and you've seen another way of doing this, which you may have, and like I said, we need to focus on the use of our TI-84. So we are talking about without replacement. And if you're not going to replace, This is actually equivalent to 52 outcomes to begin with. We pull a card out, we put it off to the side. Remember, when we're talking about outcomes, we multiply. Now we don't have 52 cards in our deck anymore. We have 51. Okay, now we have 51. We're going to pull out a third card. We have the first card, the second card, now the third card. So if we pulled out 2 cards, we only have 50 left. So if we take our calculator and multiply those 3 things together, let's see what we arrive at. 52 times 51 times our 50, and we enter same answer. So it depends on how you feel as to what you want to use. So we get the same answer. 100, 100. If I could write, we'd be okay. All right, let's erase that little. Okay. Okay. 132,600. Okay. As things get more complex, it is going to be within your best interest and speed during the test to simply use your calculator for these items. Okay, let's go to the next problem.
Number 4. In a game of cards, a player is given a hand of 5 cards. How many different hands are possible? In this situation, it's going to be different from number 3, the last question, because we're not asking for the entire sample space. We're asking for 5 cards in a hand. So what we really want is a combination of 5 cards. So in these 5 empty spaces, how many different combinations can we create for those 5 spaces? Well, how do I know it's a combination? Well, let's think about this. The order doesn't matter actually, and that's one way that I know is I can have 5 cards in my hand, I can shuffle them about, it doesn't matter, I still have those same 5 cards. Those are my only options. So we are going to use the NCR option on our TI 84. Let me clear out my TI 84. Okay. All right, so we're going to use this quickly to come up with the actual answer. So alpha, window, number 8, and right away we know that we're going to put, or we need to put, our total number of options. Well, that's 52 cards in our deck. Arrow over, we're only looking at 5 empty spaces, 5 possibilities of combinations, and that's actually the value that we need. Okay, so let's write that down real quick. 5, 9. We're going to compare that to using the equation. Please make note that this was done very quickly on our TI-84. Now let's try that with the equation. Okay, so we're going to have n possibilities, which is n factorial, 52 cards in a deck, 52 factorial. Now, n minus r, that's 47 factorial times our 5, our r options, the 5 cards in our hand. So let's put that into our calculator and take a look at what we get. All right, so we have 52. Always put your number in first. Alpha, window, and 9. I'm going to use, oh, excuse me, not yet. I'm going to divide, then parentheses, 47, alpha, window, 9. And I have to multiply after each factorial or it will give me an error. The calculator just simply can't do that. So 5, alpha, window, 9, close my parentheses, press enter. Yes, I do have the same answer. The difference is that it was quicker to use the NCR option, and there's less or rather fewer ways to make mistakes. Okay, that'll be the last question on this first video. Please have your eye out or look for our competency 16 video 2. It will have more multiple choice options in that video. And also, please refer to the resources and references at the end of this video. Thank you for watching.